What's up? In this tutorial, we are going to cover how to animate a PCG graph. When we set up our PCG graphs, any type of PCG graphs, we can have parameters inside of our graphs, and any of those parameters can actually be animated from outside of the graph. And this can be done both through Sequencer for cinematics, and it can also be done through blueprints. And I'm going to be covering a tip for how to optimize this process and help it run a little bit more smoothly. This is actually a video I shot for Aziel Arts Academy students. If you really like this video, you can find hundreds more and counting in the Aziel Arts Academy private community. You can find a link to that and where to get private coaching from me and courses and all that good stuff in the link in the description. All right, let's get into it. So I have here a PCG graph that we're about to build and a sequencer. So let's go ahead and just make those components really quick. I'm going to close my sequencer here and I'm going to go ahead and delete my PCG graph. All right, so let's go ahead and make a blueprint. We'll right click and make a blueprint, and we'll choose an actor and we'll make it BP _ growing bushes. And the reason we need to make a PCG graph inside a blueprint is that we want to control a variable, and that variable is accessible in Sequencer through a blueprint, but not necessarily through the PCG graph if we just dragged it into our world. So we need to make a blueprint with the PCG graph inside of it in order to control the PCG graph through the blueprint, then we can animating it through that way. We'll go ahead and open this blueprint here. I will go ahead and make a new PCG graph here. We'll call it PCG bush grow, and we'll drag that in here. Actually, we'll make a PCG component in here, and then we'll drag in this PCG graph into the field inside of our blueprint. So now we have a blueprint with a PCG graph inside of it. Now we need to tell the PCG graph how big to be. When it's inside a blueprint, it doesn't actually know its bounds. So if we're making a PCG graph in a blueprint, all we have to do is come to the add button and choose box here, and we'll choose a box collision. And this is going to just be a volume for the PCG graph to pick up on and know how big it should be. Then we'll go ahead and hit compile. And before we go any further, I'm also going to add the variable that we'll use to animate. We can animate any number of variables. The variable I'm going to make is for defining the density of my PCG graph, and that will kind of have it grow, the bushes grow in through that. So I'll come to my variables here and we'll add a new variable in our blueprint, and we'll call this bush grow, and I will switch it to be a float. Now I want to enable this eye here because this will let me just test it outside in my blueprint. And I also want to come over here and choose expose to cinematics. This is going to let us pick it up inside Sequencer and then actually animate it. Otherwise, when we try to find it in our blueprint that we've added to Sequencer, it's not going to show up. So this is very important here. Now we'll go ahead and hit compile and save, and we'll come into our PCG graph now. And let's just add a few simple pieces of logic here. We'll just get a landscape data node. We'll do a surface sampler, and the surface sampler will go into a transform points with a random rotation. And then we'll use a static mesh spawner to pick up a bush mesh here. And I'll just add a bush, and I'll also add a random scale here in the transform points. Okay. So now we need to go and get the variable that we made in our blueprint and have it control a parameter in the graph. So since our blueprint has a nested PCG graph inside of it, the PCG graph will look at its parent and say, okay, I can get variables for my parent. So if we come into the PCG graph and we choose get actor property rather, this is where we can go and grab a parameter from our parent blueprint. And all we need to do is make the parameter the exact same name here in the property name. And so I'll double check what that was, bush grow. And then I'll come back here and I'll type in property name, bush grow. And if there's no error, it means that it's picked up successfully the parameter from the parent. So now we can expand our surface sampler here. And what I'm going to do is I'm just going to use this points per square meter here and plug my bush grow into my points per square meter here. So I'll do and plug that in. And now our graph is pretty much good to go. So if we contract this down and we go ahead and drag this into our world, and I'll go ahead and expand it by just expanding the size of the blueprint. And we can come over to our parameter here that showed up on the outside of the blueprint. Remember, we turned on the eyeball here. on our parameter, which is why it shows up here outside of the blueprint. So now that we've dragged it in, we can go ahead and start dragging this up, and this will affect the actual density of our bushes here. Hey, just wanted to jump in here and mention that if you would like to use the exact same landscape material that I'm using in this tutorial, I am right now giving that material away for free. This is a really robust landscape material that I have built from the ground up with all of my tips and tricks. It supports auto material functions as well as landscape layers. It's kind of a hybrid material, and it can apply to lots of different situations, and it is a very high quality material that supports nanite displacement, runtime virtual textures, distance blending, color breakup, and even a super cool texture breakup function like texture bombing, but cheaper, that you probably won't find in many other materials on the marketplace. I'm really proud of this material, and I hope you enjoy. Just head to the link in the description to download it, and just, you know, it comes along with a free mini course of me teaching you how to use all the functions, and you can get the best quality out of this material. All right, let's get back to the tutorial. Now it's time to add a sequence and start animating it. So we can come down here and make a new sequence under cinematics level sequence, and I'll call this LS for level sequence, and then we will call this bush grow, and I'll double click on that to open it. Now we want to add to our sequencer the things that we want to animate. So I'll come to my growing bushes blueprint and drag that into my sequencer. Then we'll hit the plus button here on the blueprint because we want to look for that parameter that we made and that we exposed to cinematics. So we'll come here to the plus, and we should find bush grow here as a property that we can animate. So I will go ahead and animate these bushes, and we will go ahead and make them be at 0 at the beginning, and we'll go ahead and hit a keyframe by hitting this button, and we'll drag to the end of our sequencer here, and we'll go and up it to 0.1 in density. And that will automatically add a keyframe, and if it doesn't, you can hit this button again. Okay, so now we have created an animation here, and we can see that our bush growing is animating, and it's even animating in our blueprint here as we drag around, but our PCG graph is not updating. And this is the tricky part about animating PCG. Because of the way it's simulating, it's not going to update automatically from your sequencer, even if we change values from the sequencer. So we need to add a little bit of logic into our sequencer to help update the graph and refresh it as the values are changing here in the sequencer. And this is the same process that we would use inside of a blueprint in terms of animation. We would need to change the value and update the graph. Here is what we're going to go and do. We're going to come to the blueprint again, hit the plus button, and choose an event option. And there's different ways of doing this. We could trigger it. So we could trigger an update at a specific time, and just update once. That's probably the most efficient because continuously updating the graph is less efficient. And repeater will go ahead and update the event continuously. So in our case, it'll refresh the graph continuously as the value changes. So we'll choose repeater here, which will add this track here. And this track is, when we drag it over here, this is the length that the repeating event will be happening. So we'll go and drag it to encompass our whole time here that we're changing our bushes. So now we need to go ahead and bind it to the PCG graph and help it to refresh over time. So we'll right click on it, come to properties, and we'll come down to the endpoint option here. And if we hit this drop down, we can create a new endpoint. And what that means is it's a binding to this refreshing event. So we'll hit that. And what that will do is it will bring up for us a blueprint. And this blueprint is basically the blueprint for this sequence, and these events are going to be refreshed or activated from the sequence, and then we can have a logic that we attach to those particular events, and then they can happen. So this is already referencing our blueprint because we made it as an event that's as a child of that in our sequencer, so it already has that reference to that, so that's great. Now we just need to get the PCG graph from inside of it. So we'll go ahead and drag off of here and choose get PCG, and under the variables, it'll be default and get PCG because the PCG graph is a variable within the blueprint itself. So we'll go ahead and choose that. Now we have the PCG graph. Now what we need to do to update this is drag off of it and create a notify property changed from blueprint. So this will basically notify the graph. There's something that's been changed, update yourself. So we'll go ahead and choose that, and we'll plug that into the event. Now, this will now work for us if we are in simulation mode. So if we go to simulate and we play our sequence, it works. But if we want to just have this work outside of our game at runtime, and we want this to more work in the editor as well, what we can come to is this event, click on it, and make sure we choose call in editor. That will update and sort of activate this from our sequencer, not only in runtime when it's playing it through runtime, but also while we're scrubbing around in our editor mode. So we'll go ahead and hit compile and save. And now we'll go ahead and test this out. You can see now it works. So like I said, this event here is updating continuously the PCG graph as this variable is changing. So we're doing two things at once. We're updating the variable, and then we're updating the PCG graph to look for changes, which then refreshes our nodes. Okay, so that's the basic setup for getting the animation to work in your sequencer. However, this is a very simple PCG graph. I have built, and you will probably build, many more complicated graphs than this that have a lot more points, a lot more meshes, and we're not really going to be able to use this continuous update function here as is if we want it to run smoothly in our viewport and also not crash continuously if you have a really complicated graph. So I want to cover a type of optimization that I'm going to add to this updater in our nodes, and this will be a good segue into actually setting up an animation in a blueprint in which we will do the same. So I'm going to come back over to my event logic here, and if we've closed it for some reason, we can always come back to it by right-clicking on the events, the updating event here, and coming to properties and the endpoint under event here. And if we hit this little icon here that would normally look for something in our content browser, but in this case it's a blueprint related to the sequencer. So if I go ahead and hit that, it will go ahead and open up that blueprint for me again. So this is the blueprints we set up, and we have our events, and we have our PCG, and we have our updater that tells the PCG graph to update. Now we are running this kind of continuous event many more times than we actually need to. Even if we ran it, 0.02 seconds, every 0.02 seconds, it would still look like it was real time, but it wouldn't be quite the load for our system to update it quite so many times in our viewport. We only really need to update maybe 30 times a second max, and even less than that would probably look fine in our sequencer. So let's go ahead and add a little bit of logic to have it update not quite so often. I'm going to go ahead and make a do once node. This does exactly what it says. It's going to do something once. What's helpful here is that we have a do once here, and then we also have a reset. So what we're going to do is plug this right here in between. So every time that this continuous event is updated here, it will go ahead and once update our PCG graph. But that's not really good. We need it to update more than once, but we're going to use this do once node to kind of slow down and have it update every once in a while. And so for that, we'll use a delay here at the end, and we can choose any kind of number we want here. 0.2 would be a good place to start, and we'll come and drag off of this complete here and then plug it into the reset of the do once. So you can see what happens here if I move this up, and I'll drag this down here. A little more visually obvious what's happening. So what's happening is the event is updating. It's doing once, so it's going through this node once, updating, and then it's waiting 0.2 seconds and then resetting the node. So even though this event is continuously sending, firing notifications to update, it's only going to let it through to the actual update node here every 0.2 seconds. And we can maybe even make it even less, like 0.02 seconds. And if we hit compile and save, now when we play, it's going to look very similar to what we had before, but it's going to play a lot more smoothly especially when we're dealing with more complicated PCG graphs. And what you'll run into is if your machine is not able to update it fast enough, it'll basically just stop. It'll update to a certain point and your graph will just stop updating, and then it'll play to the end, and then it'll update everything. That's what it happens to me when I have a more complicated graph and I'm trying to animate it. And then what I'll usually do is I'll come in here. If I want it to really scrub smoothly in my viewport, I'll keep increasing this up to like 0.05 or 0.1 until I get, a nice mix of, not updating all the time, but it still looks smooth enough for me and my computer can handle it. But if you render, an offline through the sequencer into into the movie render queue, you don't have to worry about this quite as much, but this is going to be an important optimization when we move to our next step here, which is to set up a similar animation, but through blueprints. So some of you may not want to use the sequencer. Some of you want to instigate this at a certain point in your, well, during runtime. And so let's go ahead and add a little bit of logic into our blueprint, which is going to be very similar to this. So I'm actually going to go ahead and come over to my growing bushes blueprint that we made, which, if you remember, is the blueprint that has this PCG graph inside of it. And what we can do here is, we'll drag off of event begin play, but you could always make your own custom event. And we will go ahead and make a timeline. Timeline is a simple way to add particular animation inside of a blueprint. It lets you animate a value over time. And so in this timeline, we're gonna go ahead and you can see it has a bunch of inputs. Has play from start. I'm actually gonna move this to play from start. So we're always playing from 0 and animating up. This output here is gonna be basically instigating another node to update. And so what we can do here is come over to our bush grow, and we'll drag off here and we'll choose set bush grow. Now we need a value from the timeline to update our bush growth, right? Because it's not being animated in our sequencer here anymore. In fact, I'll just go ahead and close that so it's not active anymore. So we need a actual value to update, and that's what we use the timeline for. So what we'll go ahead and do is double click on the timeline to open it, and we'll add a track. We have a bunch of different types of animation tracks we can add to a timeline. I just need a float track, a single number. So I'll go ahead and add a float track, and this is exactly the same as sequencer. We play through time from left to right, and the value is up and down. So we'll call this bush grow, and we'll start it at 0. So I'll right click and add a keyframe, which is basically just a bookmark in time like we talked about. And so this is going to be at time 0. You can enter specific values up here. Value 0, time 0, and then over, let's say 3 seconds, we want this to grow up to, I forget what I did, 0.2 or something. We'll go ahead and we'll right click and add another key, and this one we'll call, or we will rather put in the value 0.2, and we'll put it at time 3 for 3 seconds. And we'll go ahead and hit F to frame our keys again. Okay, so this is the length of our animation. And so we'll come up here to the length and go ahead and drop this down to 3 seconds so that it's only going to play for 3 seconds. Otherwise it would play through the animation and then just kind of like, I guess it wouldn't be that bad. It would just kind of play till 5 seconds and keep updating the graph. So we just want 3 seconds here. So we'll go ahead and hit compile. And if you wanted this to loop, you just need to make sure you come up here to this button and click that on so that the animation loops. I'm not going to have it loop here. I'm just going to have it play once. So I'll hit compile and save, and we'll come back to our event graph. So now you can see a new output comes out of our timeline, which is our actual animation for our float. So we'll plug that into bush grow, and we'll plug the update into the set node here. And I'll go ahead and have a delay here. So I'll add a little bit of a delay before this plays. So on begin play, wait for 2 seconds, and then play from start. Go ahead, compile, save, and let's see what this looks like. So I'll go ahead and play in the viewport. So you'll notice, again, nothing happens because we don't have that graph continuously getting the instigation to update. We're just getting the animation and it doesn't know to update. So we're running into the exact same thing that we ran into with our sequencer. So I'll go ahead and hit stop. I'll come back here and we'll go ahead and put our other node here, which is update or notify property update changes from blueprint. Okay. And it grabs our PCG. So it knows that it's related to that. And we will go ahead and add our little bit of optimization in here as well. So I will put we can put it here in between. So I can do once, and we'll put that in between here, and we'll do a delay here, and we'll make it 0.02 seconds, and we'll on complete reset. And I'll double click here to add a redirect here just to keep it organized. Hit compile. Let's come back here and let's go ahead and hit play. So great. So now we're getting the full animation updating as we want, but one problem is that when we start playing, it's not actually starting at 0. So what we can do is we can come over here to our blueprint and go ahead and enter the bush grow into 0 here to start. That would work. And if we hit play, then we would go ahead and play from the beginning. Or if we wanted to, we could come to our blueprint here, and we could add a little thing here at the beginning that sets the bush grow to 0, just in case we've messed around with it. That will go ahead and update that to 0. So now we can go ahead and play around with the bush growth, but as soon as we hit play, it will update to 0. Oh, I need to make sure I add the update node. So go ahead and add another update node here, copy and paste it. So we'll set it to 0 and update the graph, then delay 2 seconds, then start the timeline. File save, and then we'll go ahead and hit play. Start to 0, waits 2 seconds, and then plays the animation. All right, hopefully you found this video helpful. If you did, let me know with a thumbs up or a comment if you have any questions. Like I said, this video comes from inside Avial Arts Academy, where you can find hundreds more videos exactly like this, and I shoot custom tutorials directly for you on your questions. You also get access to me with regular coaching calls, and all of my online courses are in the Academy as well. If this sounds like something you might be interested in, you can find a link in the description to jump into the Academy. Otherwise, I will see you in the next one.